Hello and welcome back to another standalone tutorial. Today's topic will be achieving persistence in your game. And if you're not familiar with the concept of persistence, it is a common problem of how levels are handled in Unreal Engine 4 and probably in most other engines too. The thing is that levels are completely separate entities in Unreal Engine. That means when opening another level, all of the actors from the previous level are destroyed and therefore all of the variables will be reset and you're not able to carry across data. So in cases where you want to use different levels and still keep some of your data, for example like a score, which we will set up in a second, you will need to come up with a persistence system. I already created a blueprint project here with the third person template as the baseline. The only thing I adjusted here is the camera, which I just moved backwards a little bit, and you can see that I already added a folder called persistence. I just moved the third person character and game mode from the third person BP folder in here and created a material and a particle system, which we will use later. So just so we can focus on the actual code and not on materials and particle systems, I already created these. Let's start by adding a folder here and let's call that maps or levels, whatever you want to call them. Then we'll go to third person BP, open up the maps folder and move the third person example map and the lighting data into our custom maps folder. Then we will select the third person example map, hit F2 to rename it, and we'll call this level underscore 01. Alright. Then we need to create some kind of data that will later be made persistent. So let's add a little bit of gameplay. The idea is that we will simply have some pickup actors in our level that we can approach to increase our score. Let's start by displaying this score on the actual HUD. So let's create a user interface widget blueprint called w_main. And it's very simple here. You only need a basic text element and let's call that the score text. Make it a variable. Now we have to define where we want to display that text. I'll just say we will use the upper right corner. Then I can set the alignment to 1 and reset the position in X and Y to 0 so it appears at the very corner. The default text will read something like score 20. Let's also increase the size here to something like 370 in X and 90 in Y. So that way we can increase the font size here. Say to something like 55, that should work. And then I will give it an opaque shadow and increase the shadow offset in Y, something like 5, just so the text stands out a little bit more. Right, that's it already for designing the main widget. Let's head over to the graph. And we only need one function in here called update score text, which will simply read one input of type integer called value, and it will make our score text read that new value. So drag in your score text, set text. Then for the int text we will use a format, and here I'll type in score, add a white space and in curly brackets value. If you then hit enter, you get an additional pin for the value, and we could just plug in the input, but let's convert that to a text first and uncheck the use grouping here. Alright, let's compile and save. Then we have to keep track of the current score in the third person character. So let's open up the third person character, add a variable here called something like current score, and let's say we will make that an integer. No need to work with floats. Then we also have to display the main widget. So on begin play in our character class, we will create a widget of type wMain and store that in a variable so we can access it. Just call that main widget ref for reference. Then we can call the update score text function and plug in our current score as the value. And after that, drag in your main widget, and to finally display it, we will add it to the viewport. Right, so if we hit play now, our text should read score 0, which it does, so that's already working. One thing you notice is that if you hit play, you will start with the mouse cursor being shown, and only once you've clicked it will disappear. To fix that, simply get the player controller on begin play and off of it set input mode to game only. Right, so that way when we hit play the mouse cursor is instantly hidden. Let's also add a function here called modify score, which will have one input of type integer, which will be the amount to modify our current value by. So let's just call that by. And we want to set the current score to its value plus the by input. And just to make sure it doesn't go below 0 or above a certain value, we will clamp it minimum of 0 and maximum of 999. Then we can hook up the return value to the set node and hook it up to the function. To display it, we would need to call the update score text function of our main widget. But let's just check whether the main widget was already created, so is valid. And only if it is valid, we will call update score text. Again, the value here will be the current score variable. So we've got functionality here to modify the current score. We also need a way to call this function. So let's create our pickup actor, add a new blueprint class of type actor called bp_pickup. And let's open that up. For components, it's very simple. We will simply add a box collision. So that will handle detecting when the player is nearby and removing this pickup. So the extent will be 100 in X, 100 in Y, and let's say 300 in Z. So also move it up by 150 in Z. And then we will add a sphere shape, not a sphere collision, and attach that to the default scene root. I'll scale it down by, let's say, 25%, so scale here will be 0.75. For the material, I will use the mi_pickup that I created. So you can see this translucent blue sphere. Also move it up in Z by 150. And we will scroll down and disable the collision here, so no collision. Then let's head over to the graph. And actually, if we have a look at the mi_pickup, it contains a variable called opacity, which we will animate to slowly fade it out once it has been picked up. And to do that, we need a dynamic material instance. So grab your sphere and create dynamic material instance. We'll be asking you for the index, material, and name. We only worry about the source material, and to get that off of your sphere, get material and simply leave the index at 0. Then plug that in. To modify our opacity later, we will have to promote that to a variable called dynamic material, and that way we can later modify it. Let's select our box in the components and implement the onComponent begin overlap. Let's check whether the actor we're overlapping is the player. So let's grab the other actor and cast to the third person character. If you're using another template, for example the top-down template, that would be the top-down character, and so on. If it is the third-person character, we will first go into a do-once node, just to make sure that the following logic is not executed multiple times. And then grab the character, and we will call our function modify score. Let's say every time you pick up an actor here, it's modified by 10. Then we want to slowly fade out the sphere here, and to do that we will add a timeline. And just call that fade out. Then if you double click, we can go into that timeline and add a float track. Let's just call that value. Then you can modify the length. So our animation should be very quick. We'll just say a length of 0.5 seconds will do fine. And then we need some keyframes. So we will right click and add a key to curve float, and at time 0 our opacity will be 1. And add another key at time 0.5 seconds, our value will be 0. And if we select these two keyframes, we can right click them and say the key interpolation will be defined by the user, and we can just drag it to create an ease out animation here. Alright, let's close our timeline and compile and save. Then once we've modified the score, we will play the timeline from start, and every time it updates we will get the dynamic material and set scalar parameter value. The parameter name will be opacity, make sure that it's spelled correctly, and the value will come from the timeline. Then once that is completed, we will simply destroy the actor and compile and save. That's it already for the pickup actor. We can close it and just put some BP pickups in the level. Then if we hit play, we start with a score of 0. And once we approach the first pickup actor, it will fade out. Our score was modified by 10. And we can get the other ones, so 20, 30, 40, and finally 50. So the pickups are properly working. But since we're talking about persistence, we're currently using just one level. Let's change that. Go into maps, grab the level 01 and duplicate it to level_02 and open it up. Then save selected. Just to make it look differently, we will remove all of these static meshes here. And let's also remove the pickup actors. Then let me grab the skylight and just change the light color a bit to something like a light blue. Then we can grab some pickup actors and drag them in here. And make sure to build the lighting afterwards. I'll just skip the process for you. Alright, the lighting was built. And if we play in here, we can also pick up these pickup actors. However, currently there is no way to travel between the two levels. So let's go back to level 1 and we will create another blueprint class of type actor called BP_teleporter. So once we touch a teleporter, another level will be opened up. In our teleporter, let's also start with a box collision. The extent here will be 100 in X, 90 in Y, and 180 in Z. Then we'll move that up in Z by 110. Second element we need here is some kind of visual representation. So that is where the particle system comes in place that I made. So add a particle system, attach that to the default scene root. We will reset the location, and as the template, I'll select the p_portal. That's just based on the fire particle of the starter content. Let's head over to the graph and let's give this one a variable called toLevel. So this variable will just be the name of the level we want to be teleported to. So variable type will be a name. It has to be editable and exposed on spawn, so we can define it per instance of the teleporter class. Then we can implement the onComponentBeginOverlap of our box. And again, we need to check whether it was the player. So other actor cast the third person character. And if it is the third person character, we will simply call openLevel. It will be asking you for a level name, and that is where our toLevel variable will feed into. Path save. We can close the class and place a teleporter on that platform here. We're currently in level 1, so this needs to teleport to level_02. Then let's open up our second level and place a teleporter here, which will then teleport to level_01. Save it. And let's head back to the first level. So now I can show you the issue of working with levels in Unreal Engine. Let me hit play. So picking up some actors here. Currently our score will read 50. Now if I try to touch the teleporter, I'll be teleported to the second level, and you see that our score was reset to 0. That is because this third person character here is a completely different instance of the third person character class and has nothing to do with the character in the first level. So that is why the score is reset. And same thing is true for the second level. So if we pick up some actors here and teleport back to level 1, that was also reset. To work around this issue, you have to use a class that is persistent, which means that it is not bound to a level and therefore not deleted when switching levels. Fortunately for us, there is a class for that called GameInstance, and to create one you simply go right click blueprint class, and under all classes look for GameInstance. Use that as a parent class, and let's just call that GI for GameInstance_persistence. Creating that class won't do anything at all because you never told your game to use this GameInstance class. To do that, you have to go to Edit, Project Settings, to Maps and Modes. And if you scroll down, there is a GameInstance class. Looks like the engine automatically set that to the GI persistence, which is good for us, so that is already used. You might have to select it here. Let's open that GI persistence. And now you have to figure out which of your variables will have to be persistent. In our case, it's the score. So let's add a variable here called player score of the type integer. And we'll also add another variable called shouldLoadTransition of type boolean. And that way we will define what happens when we open up a new level. So if this value here is true, our third person character, which is created in the new level, will know that he has to load something from the game instance to complete the level transition. So that is what this boolean is used for. Let's add a function called gatherPlayerState. That function will be very simple because we're only worrying about the score, but there could be lots of different things that you want to keep track of. For example, the items found or the quests completed and so on. This function also needs an input, which will just be the player, to gather the state from, and the type here will be third person character reference. The only thing we have to do right now is to set the player score to the current score variable of the player input. What we also want to do in this class here is to handle level transitions, because it just makes much more sense to handle that in a class that is not deleted during the process of level transition. And let me also show you how you could set up something like a loading screen. So let's close the game instance for now, create a new widget blueprint called w_loading bar, open that up. Then we will just add an image to the canvas. Let's anchor it to the very last anchor here, which basically means fill canvas, and then set every offset to 0. And we can make it black. And on top of that, we will add a circular throbber, which will display the loading process basically. Anchor that to the center, alignment of 0.5 in X and Y, and then a position of 0. Say the size will be 200 by 200. The order of something like 3, just so that it appears above our image. And I'll just slow that down by a bit, so set the period to 1.2 maybe. Yeah, that looks fine. That's it already. We don't need functionality here. Back in our game instance, let's add a custom event. We will call this transition to level, and this will need 2 inputs. First off, the level to transition to, so that will be a name called level, and the second one will be the player with the type third person character. So when we transition to another level, we first want to create a widget, which will be the loading screen or loading bar. Then add that to the viewport and give it a very high Z order, something like 20, just so that it appears above all other widgets. Then we will gather the player state with the player coming from our input player. We will set should load transition to true, since we are obviously changing the level here. And then we will open level and hook up the level name from our input. So this functionality would already work. Just something cosmetic. Before the open level here, I will add a delay. And for the duration, I'll put in a random float in range, minimum being 0.3 seconds, maximum 0.7. That is just to have a little bit of time to see the actual loading screen. Our levels are very basic at the moment, so opening them doesn't require much time, and therefore your loading screen is deleted very quickly. Then in the third person character, we will add a function called getGameInst, for instance. And what that will simply do is we will get the game instance and already cast that to our custom class, so cast to GI persistence, and return that. Add a return node, drag in the as GI persistence, rename that to out, and we'll make it a pure function. Compile and save. Then we will add a function here called loadPlayerState. So here we will get the information from the game instance and set our internal variables to match these. So we will set the current score to getGameInst and then player score. After loading the player state, we can drag off of the game instance here and set should load transition to false, since we obviously did that here. Then let's head back to our event graph and use the event begin play here. Keep in mind that this event begin play also means that it's called when another level is opened up, because we're using different instances of the third person character in different levels. And after setting our main widget reference, let's add a bit of room, because we will get the game instance and get the should load transition boolean. Add a branch off of it. If it is true, we will simply load the player state and then go into the update score text node. And if it's false, we will directly go into update score text. Compile and save. Open up your teleporter class. Currently, we're still using the open level node here, but we want to use the event in the game instance. So off of the as third person character, we can get game inst. And off of it, then call transition to level with the player being the as third person character and the level being our to level variable. Compile and save. Let's close our teleporter and test whether that's already working. And if we hit play, we can grab these pickup actors. Currently our score is set to 50. Then if we transition to another level, we're seeing the loading screen, and our score is still 50. Then we can pick up these 4 pickup actors, and our score is currently 90. Going back to level 1, our score is still 90. Right, so our score is carried across properly through different levels. However, you're already seeing an issue here, and that is that when switching to a new level and then going back, all of the pickup actors are spawned again. So technically here we could get an infinite score by always going to the second level, picking everything up, going back to level 1, and then hopping back to level 2, and everything will be respawned. So that is something we want to fix. It's also not a difficult problem to solve. The only thing we need to do is keep track of the level state, and in our case that only means keeping track of which pickup actors have already been picked up and which haven't. Let's open up the BP pickup, and to identify individual pickup actors we will give it a variable called ID, make that an integer, editable and exposed on spawn. Compile and save. Then you would have to set up the ID for every pickup actor in your level. So this one will be 0, next one will have an ID of 1, here it will be 2, next one will be 3, and the last one will be 4. And you would have to do that in every level. So let's open up the second level and do it here too. You don't have to start with 5 here, just because we ended up with 4 in the last level, because levels will still be treated separately. So we can start with 0 here, then this one will be 1, here it will be 2, and finally 3. Let's save and go back to level 1. After that, in our persistence folder, we will add a structure, blueprint structure, called s_level data, and open it up. Right now we only have to worry about the picked up items. So let's call that picked up IDs and make it an integer. Then for the container you could either choose array or set. Set makes much more sense because you can't have duplicates in there. So let's choose the set. And back in our game instance, we will add a variable called level data. And the type here is interesting. So we will make it a map. The first variable type will be name, and that name will identify the level. And for every level, we will store an s_level data. So if we just were to add an element here, you could type in level_01, and then if you expand it, you could add all of the picked up item IDs that you want to have, but we will do that in code. So let's remove the elements and add a function here called onActor picked up. This needs an input. Just to identify which actor has been picked up, it will be a BP_pickup. Let's just call it actor. First off, we will get the current level name. And then we will try to find that in our level data. So level data, then find, and plug in the return value. We'll convert it to a name for you. Add a branch off of the boolean, so whether we found something or not. If we didn't find anything, means that we haven't added data for this level before. So we simply grab the level data and add an element. Here it will be asking you for the level name, so that is our return value to name. And for the structure, we will make as level data. Then you got access to the picked up IDs, and then we will make a set only with one element, which will be the ID of the actor picked up. Get its ID and hook that up here. Then we can return. If we found an element, however, we will break the structure and promote the picked up IDs to a local variable called local IDs. Then we will grab the local IDs and add an element, the element being the ID of the input. After that, drag off of the found structure again and set members. Right click it and restore all structure pins. Then for the picked up IDs, we will plug in the local IDs. Then grab your level data again, add an element. Structure will be struct out, and the name will again be the return value here to name, and after it return. Compile and save. Let's also add another function called has actor been picked up ? Let's make that a pure function with one input of BP pickup called actor, and with one output being a boolean called out ? Again, we need to get the current level name, and have a look whether that's included in the level data. So try to find it here. Add a branch off of the boolean. And if we were not able to find the current level in the level data, we will just return with false and say this actor has not been picked up. If it's true, however, let's break the structure, get the picked up IDs and check whether that contains the actor's ID. And we will return whatever the result of that is. Compile and save. Then in our BP pickup here on component begin overlap, before we modify the score, let's get the game inst of our third person character and call on actor picked up, the actor being self. After we've done that, we can modify the score. Then on begin play, before we're doing anything here, let's get the game instance and cast it to the GI persistence. Then off of it, we will call has actor been picked up with the actor being self and add a branch for the out. If this actor has been picked up, we don't have to worry about dynamic materials, we will simply destroy it. If it hasn't, we will create dynamic material instance. So when this actor here is spawned, we are asking the game instance whether it has already been picked up before, and if so, it will be destroyed. Let's play again. So we're picking up something here. Let's actually leave one pickup actor to the left here. Then we'll transition to the second level. Score remains at 40. Here we will pick up everything. And when we go back to the first level, we will see that all of the pickup actors has been removed except for the one we left on purpose. So let's pick that up, and back in level 2, there are no pickup actors here. In that sense, our game levels are already persistent. Let's have a look at how to send data from something like a main menu level to the default gameplay levels. Let's go to maps. We will right click and create a new level that we will simply call level underscore menu. And let's go in there, save everything. If we were to play here, you're actually seeing a score. So this level is still using the third person game mode. We want to change that. And first off, let's create a blueprint class of the type player controller called menu controller. Then if we go in there, under mouse interface, we will show mouse cursor and enable click events so we can hit buttons in the main menu. Then we will right click and create another blueprint class of type game mode base called gm underscore menu. If you open that up, we'll go to the player controller and select the menu controller. All of the other classes may remain the same. Last thing would be to tell this level to use the new game mode. So we'll go to world settings, and under game mode override, we will select the gm underscore menu. And now if we play, you're no longer seeing a score and the mouse cursor is actually visible. Let's add a widget blueprint called w underscore menu. Open it up. Here we need a bunch of buttons. So the idea is that there will be different game modes. You can either load a game, start a new game, or start a new game plus. And we will use the game instance to communicate which game mode has been chosen. And if it is the game plus mode, there will be changes in the actual levels. So some pickup actors will no longer exist in new game plus. Let's start with a vertical box here for all of our buttons. And we'll align that to the center. Alignment of 0.5. Position of 0. Then we will check size to content. In there we will add a size box. For the first button, check width and height override. The values I will use are 600 in width by 180 in height, and I'll use a padding of, let's say, 60 to the bottom. Then we'll add a button to the size box. Let's call the first one here load game. We'll go to normal, to tint, and make that a lot darker, something like a dark gray. Then let's go to hovered and make that something like a bright orange. Let's go to pressed, also make that orange, but just a tiny bit darker. And we'll copy normal for disabled and just lower the alpha to, let's say, 0.5 and make it a bit darker. Then I will clear the normal and press padding and add a text element onto the button. This text here will just read load game in caps with no padding. Typeface will be italic, size of 50 maybe. We'll make the visibility hit test invisible, and let's just give it an opaque shadow too and add a little bit of shadow offset in X. Then we can grab the size box and copy paste it onto the vertical box. And this time we'll call the button new game and select the text and make it read new game. Then we'll paste another one onto the vertical box and call this button game plus and make the text read something like new game plus. And we don't need padding for the last one here. So go to the size box and clear the padding to bottom. Alright, let's compile and save. That's it for the menu for now. To keep track of the game mode, we will add a blueprint enumeration called e_game modes and open that up. Currently there are only two, so let's say something like common or basic game, and the next one called game plus. That's it already. We can close the enum. Then in the GI persistence, we'll add a new variable called game mode and make that of the type e_game modes. Then in the event graph, we will add a custom event called start game. So that is called when any of the three buttons is pressed, and it needs two inputs. So first off will be an e_game modes. That will just call game mode. And the next one a boolean called load ? So that would only be true if we're pressing the first button called load game. Let's add a branch off of the load input. And right now let's only handle the false path. We'll do saving and loading later. So if it's false, we will set our game mode variable to the input. And after that open level. And let's promote the level name to a variable here called starting level. If we then compile and save, we can set that up. So in our case, it would be level_01. Compile, save, close your game instance. We'll go back to the menu controller and open that in full blueprint because we're still not displaying our menu widget. So we will do that on event begin play in the controller by creating a widget of the type w_menu and add that to viewport. We don't have to store it in a variable. It will automatically be destroyed when opening a new level. Then back in our menu widget, let's implement the clicked events of all of the buttons. So load game, new game, and game plus. Start with load game. These are very similar. We will get the game instance, cast it to the GI persistence, and simply call start game. If we're clicking the load button, the game mode will just be common and we will check load. Let's copy these three nodes for new game. If we're hitting new game, load would be false and game mode would be common game. And for game plus, load would still be false, but this time the game mode would be game plus. Right, compile and save. The information of the game mode is already carried across the levels now. However, it doesn't have any impact because the variable itself doesn't affect anything. Let's change that. So let's go back into our level 1, open up our BP pickup, and we will simply say that some pickup actors do not exist in the new game plus mode. Let's add a variable called exists in game plus ? Make it editable, exposed on spawn, and if you compile, the default would be true. Right here after the cast, but before checking whether the actor has been picked up, let's add a bit of space. We'll add another branch. Then off of the GI persistence, we will get the game mode. And let's see whether that equals game plus and whether exists in game plus is false. So add a not boolean, connect that to the end to the branch. If it is false, means either we're not in the new game plus mode or that this particular pickup actor exists in new game plus. So if it's false, we would just continue with what we had before, so the branch here. But if it's true, we will destroy this actor. Let's close it and we can set this variable per instance. So here we can set it. Let's say the first one will exist in game plus, this one here will not exist, and this one here won't exist too. Then we'll go to level 2 and say half of these do not exist in game plus. To test this, we have to open up our level menu and hit play. Right, we are seeing the three different buttons. Load game doesn't do anything. If we hit new game, we got what we had before. So 5 pickup actors in this level and it should be 4 in this one. Yep, that's working. Then if we play and hit new game plus, we're only seeing 3 pickup actors here and it should only be 2 in the second level. All right, so that's working perfectly. The only issue left is that if we hit new game, for example, gain a score of 30, close the game and restart it, hit new game, our score will be reset again. So currently our levels are only persistent in a continuous playing session. To add persistence through various playing sessions, we need a saving and loading system, which we will also implement now. We need a save game class, so add a blueprint class and look for save game. Choose that as a parent. We'll call it save game underscore persistence and open it up. Now we have to put some thoughts into what variables have to be saved. We want to save the game mode, so let's add a variable called save game mode. And the type will be an e underscore game mode. We also want to keep track of the level in which the player was when he saved. So saved level name and make that a name variable. Then we need the player location, so saved location, and that will be a vector. The saved score, which will be an integer, and finally the saved level data, so which pickup actors have already been picked up. And the type here will again be a map connecting an name to an s underscore level data. Once you've created all of your variables, compile, save and close your save game class. Then let's go into our GI persistence and add saving and loading functionality here. First off, we will add a boolean called load game ? So that way when the game starts, our third person character can check for the game instance whether he has to load the game, and if so he can do that. And then let's start with a function to save the game, save game. Then here create save game object of the class persistence. Promote that to a variable called save game object. After that, drag in your save game object, and we need to set all of the variables. So for example, let's say we will start with setting the level data to our level data variable and hook that up. Then we will continue with setting the saved game mode to our internal game mode variable. After that, we will get the current level name and then drag in our save game object and set saved level name to the return value converted to a name. After that, we will get the player character, because there are some variables we can only get from the character himself. Cast it to third person character, and if that cast here succeeds, we can grab our save game object and set the saved score to the current score of the third person character. And after that, set the saved location to get actor location of our third person character. Let's hook these two up. Once we've set all of the variables, get your save game object and call save game to slot. We'll be asking you for a slot name. We'll promote that to a variable called save slot name and compile and save. We can type in something here like save game persistence, doesn't really matter. Also, if the cast fails, we'll use the save game to slot node 2. And here at the very beginning, where we're setting the save game object, let's implement a check whether the save game object is already existing, so is valid. And only if it's not, we'll create a save game object. But if it already is, we'll just skip to the set level data node. All right. Then let's add another function called load game. That one is much simpler. Again, we get the save game object, check whether it's valid. If it isn't, we will call load game from slot. Slot name being our save slot name. And you need to cast this return value to your save game class. So save game underscore persistence, and then set the save game object variable. After that, we'll get the save game object and get its level data. Then we will set our internal variable to it and also hook that up to the isValid path. Then we'll get the saved game mode and again set our game mode variable to whatever that value is. We will also set the player score to the save game object saved score. And after that, we can set load game to true and return. what we also want to return is the save game object's saved level name. So we can use that. Just drag that onto the return node and call it level. Then compile and save. That's it for our two functions. We can now go to the event graph and the true path of our start game event, because here we will simply call load game and then open level, with the level being the return value of our load game function. So that is why we had to return it here. Our third person character also has to load some variables. So let's open up the third person character. And in the event graph here, we'll go to begin play. Before checking for should load transition, we will add some room and copy our get game instance and get the load game boolean here and add an if statement. If it's false, just proceed with the next branch. But if it's true, off of your game instance, we will set load game to false, then load the player state, so that we get the player score and set our current score to that. And finally, we will set actor location. And to get the new location here, get the game instance, get its save game object, and then off of that, get the saved location. Plug that in for the new location. And once we've done all of that, we will proceed with the next branch. Path save. Also, let's add a way to save the game. I'll just use a key, in this case the L key. Let's look for L key, scroll up a bit and use that one. So when pressing L, we will get the game instance and save game. And after that, just use a little print string node, which will read game saved. All right, save. Let's go back to our menu widget. Right now, the load game button here is always enabled. We only want to enable that when a save game exists. So let's copy our game instance and cast node. And we will use that on event construct. Then off of your game instance, get the slot name, so save slot name. And we will look for does save game exist. Slot name being the save slot name. And to use this value, we will get the load game button and set is enabled to whatever the return value here is. Let's compile and save the menu. The last thing you should do is go to Edit, Project Settings, under Maps and Modes, and set the editor startup map to your level menu, and the same thing for the game default map, level menu. Now we should be able to test and everything should work. So if we play for the first time, the load game button is grayed out, we can't press it. Let's start a new game plus. You can see our 3 scores here. I'll just pick up 2 of these in this level, then go to the next level, pick up everything here. Score right now is 40. Then I hit L, game was saved. I can start the game once again. Now I can hit the load game button, so let's do that. And we're in level 2 with a score of 40. It also saved that this here is game plus. And if we teleport back to level 1, we can only see the one pickup actor that was left off that we can now pick up. Alright, so that is how you can set up persistent level data using the game instance and save game classes. I hope you enjoyed it, and it's the end of this episode, so see you in the next one.